Well, today I'm going to be talking about 3D printing for ham radio. And I kind of got into this because I was interested in a lot of just how like maker skills intersected ham radio. And along with Nan, we started the ham pie group that deals with things like 3D printing, Arduinos, Raspberry Pis, and how you can incorporate those kind of things into your ham station and ham activities. And I am by no means like the world's greatest expert on 3D printing, but I have learned a lot. And I'm giving this presentation with the, if I can do what I have done in this amount of time, anyone who is sitting on the fence and thinking about doing it, I would encourage you to do it. You can do it too. Next slide, please. So what I'm going to do is, I don't know what everyone's background is. So first, I'm just going to give a general overview of the 3D printing process and kind of things you need to consider if you've never done it before and you're thinking about getting into it. And then I'm going to give a few examples of things that I designed very early on in my journey into 3D printing. And I'll end up with radio specific examples because we are hams and we're here for radio stuff. Next. So if you're thinking about getting into 3D printing, this is the basic list of things you need. It's not long, but if you don't have anything on this list, you're going to be lacking. So of course you need the printer, you need some sort of filament. And for the purposes of this talk, I will be focusing on the kind of like home scale filament printers. I won't get into things like resin printing or more complex materials because those are usually beyond kind of the cost range of people who are getting into the hobby. You need something, a design, usually a .stl format file that can be generated with a CAD program. And then you need a computer to either make or get the design and to translate that design into a language that your printer can understand, usually in something that's called G code, which is just a series of coordinates, X, Y, and Z, that your printer will move on to print things. Next slide, please. So this is the kind of general process. You figure out what you want. The nice thing about being a ham is a lot of people might want the same things as you. So those things might be already designed, and there's online repositories where you can download designs. You don't have to design from scratch everything you might want as a ham radio enthusiast. So you can either design yourself or get from online repositories that 3D model. You do this process called slicing. That's that translating into a language the printer can understand. And that's done by usually a program that comes with your printer, but there are standalone slicing programs if you want to get like really fancy or, you know, and make interesting supports for that kind of thing for it. You transfer your design file to your printer. You load in your filament, and sometimes you have to level the printer the first time you set it up or do some other you know, like initial steps. Print your model and then take it off, and usually there's a few rough edges or maybe some supports you have to remove, so you can take those, sand it a little bit if you want, paint it, and then you're ready to go. Next. So this is just kind of, this is a very basic 3D printer. And so the parts on it are, there's an extruder. This is basically, I think of it as kind of a glorified hot glue gun. This is where your filament comes out. The filament is plastic that is melted, goes through the extruder. You've got stepper motors that control your X, Y, and Z axis. There is a build plate. This is where the print gets made. Sometimes this is heated. If you have an option to get a heated one, if you're debating between the two, get the heated one. It makes a big difference in how well your prints start. And then there's usually some sort of control thing for changing settings on the printer itself. More fancy printers will have an enclosure, and for some types of filament, that's really important. Next. If you've never seen a printer in action, how many people, has anyone here never seen a 3D printer in action? Like, show of hands, never seen. Okay, so good, I'm not wasting time. So I have a video because a question I get from people like at work when they're trying to figure out how to, they're like, what does this even look like when it's going to print? So if you would hit play, this will kind of show you the process. And it's important to kind of understand how printing works. It's layer by layer. The extruder is squirting out a thin filament of plastic in a very precise pattern. And for thicker edges, it'll just do the whole edge. And then for areas in between, it will do a zigzag pattern to kind of fill in any gaps in between. So it does an outline, and then it fills in all the gaps, and then it does an outline and fills in all the gaps. And it's building layers. And it's important to realize how it prints in order to make sure that your prints don't fail when you try to do them. Next, please. We've got it. Keep going. So when you're trying to decide what filament to have for your printer, the two main options for these consumer level ones are PLA or ABS. PLA, you may have seen sometimes you get like biodegradable spoons or forks or other plastic items. Sometimes if they're not clear, if they're kind of an opaque plastic, they might be made out of PLA. That's where you most commonly encounter it outside of 3D printing. ABS, if you've seen a Lego, that's made out of ABS. So there's some differences in both the properties and the end use where you might want to use one or the other. So PLA is definitely recommended for beginners. It's easier to print because it prints at a lower melt temperature. So you're more likely to get successful prints with it. ABS is a little higher melt temperature. It's more durable. It's more flexible. PLA is actually stronger, but in the way that glass is stronger than plastic, it's also more brittle. So it's easier to crack. PLA is biodegradable, which is a big plus for some people who are concerned about the environmental impact. It's a plant-based plastic. ABS is not. And more importantly, at least for me, when I print, PLA doesn't have any toxic fumes associated with it. It does have a smell. I would never print without ventilation. I always run a fan, and I run my bathroom fan around the corner when I print with it. But it's not required. If you're printing with ABS, some of the fumes associated with are a little bit nastier. You probably don't want to breathe them in. So you really want to have a well-ventilated space where you're printing if you're going to work for ABS. And PLA is also better on an entry level because you can have one of those cheaper open printers like the one I showed you kind of on the anatomy of the printer slide. For ABS, you have to have an enclosure in order to keep that temperature high enough around it, or be working in a very warm room alternately, I suppose. But so it takes a better printer to print with ABS. And I want to emphasize that both these filaments are best for use either indoors or temporarily outdoors, especially PLA, because it is biodegradable. You'll read things that are, oh, it'll only biodegrade under, hot compost conditions. This isn't true. I put PLA things outside, like I made a flower pot, put it with potting soil. It was completely brittle and falling apart. Well, like 5 or 6 months later. So you don't want to make an outdoor antenna support that's going to be sit there and exposed to the elements out of PLA. And you probably don't want to print it out of ABS because it doesn't really have the properties that are going to make it like photo stable. It will photo degrade over time. So this is great for in your shack, in your attic, if you've got a POTA station, if you've got a station where you're, got a handheld Yagi where you go outside and do satellites. These are all applications where printing something would be useful. Next. As I mentioned before, so I'm going to kind of go through like the process now with some more detail. So I mentioned before, you got to get your design. So what does that look like? Well, my favorite place to go is someplace called the Thingiverse. There's other online repositories. If you see, so thingiverse.com, if you wanted to look at the slides later and remember where it is. And so for this, I just searched for a wire winder because I thought that may be a practical thing to have. And you can see this is just some examples. Not everything may be radio related. Some things may be for headphones or whatever, but you'll probably find something you can put ham radio, and that will frequently narrow down the search. And then when you find an item, you're just going to click on it, next. And then it'll bring up a thing file. So all the things that anything in this talk that comes from the Thingiverse will have this thing number. So if you want to go and print off one, you can just look back at the slides and do it yourself. And where you click is, you click where it says thing files. Sometimes there'll be more than one piece that you have to print. Each one of those will have a separate .stl file, and you just click download. I've run into problems recently with the Thingiverse with the download all feature. So if it doesn't let you download all, don't give up. You'll just have to download them individually. They had a problem with people like bots kind of hacking and doing that. And so they've made that process more cumbersome. And all these things usually have a license with them. Most of them, if you're not going to sell it, if you're just using it for personal or educational use, you're ready to go. You can tip to the designer if you want, but if you don't have to, most of the things on the Thingiverse are free. There are other sites where you have to pay, but it's usually not super expensive. So if you don't want to have to reinvent the wheel, if there's already something that someone else has made, this is a great source for that. Next. Alternatively, you may not find what you want already on the internet. And so you may want to make your own design. Now, a whole bunch of you are engineers, and so I know you probably have access to things like AutoCAD and other professional CAD softwares, and you don't really need to pay attention to this in the next slide. But if you are not an engineer or don't have access to these things, there's some really good free programs. The one that's I think is best for beginners is called Tinkercad. It is web-based. It is limited in what you can do. You can't make super complex, fancy designs, but for things made out of basic shapes, it's a really good tool, and it's an excellent way to learn how to use a CAD program if you've never used one before. It was originally designed for like middle school and high school kids to learn how to use CAD programs, and is been bought since then by AutoCAD. So it's kind of a training version of professional CAD software. So it comes with all these tutorials. When you first open an account, it will just drag, like it'll say, drag a piece here, now make a hole in it, now put these pieces together. And it's really intuitive. And it's a lot of fun, quite frankly, to use. I've used it not just for doing 3D printing things, but when I've done like carpentry projects, I like make pieces the size of all the boards and I put them together. And it's a really great way to kind of just like plan out any kind of construction project. So once you have something there, then you can download the .stl file, and then you can put it in your slicing program. Next. So this is what the slicer for my printer looks like. Everyone's is different. You have kind of a model of what your printer bed looks like. You can usually, if you want, you can sometimes print multiple versions of the same thing and just kind of move it and drag it around. One of the important things that it will ask you about, and I just use the default setting unless I need something that's very light or very dense, is infill. Infill is any place there's solid pieces inside of this printed thing. It's not going to be solid plastic. That's really time intensive to print, and it's really wasteful because you can get a really strong print and it not be completely solid. So infill is kind of a crisscrossing, like honeycomb design that supports the inner part of solid shapes. And if it's at 100%, it's completely solid. And if it's at 0%, it's completely hollow. You can also mess with things like how fast you want, what temperature you want your extruder to melt at, how fast it goes. Maybe if something's really hard to print, you may want to slow the speed down to give it a little more time to cool so that it's less likely to sag. So you can tweak all those settings in your slicer, and then it translates your STL picture into the G code that your printer needs to print. Next. So this is just an example about when I was talking about infill. So here's the hollow with 0. Usually somewhere in the 40% range is what most people print at. For under normal settings, I usually print at about 30. And then if you want something to be just a chunk of plastic and take forever, you can print at 100%. Next. So I'm going to go through kind of a few design considerations. And anytime you're designing something to print, and anytime you're positioning something for printing for slicing, you have to think about printing like you think about a masonry project, not a carpentry project, not a machining project. If you are building something out of bricks, you're building like a printer, layer by layer. And if you've got something that's overhanging, you have to support it until it dries. And that's exactly what happens when you print. Next. Anytime there's a gap or space, the printer will automatically print something called infill. Not infill, supports. Will print supports. And this is kind of loose, brittle plastic that you can easily break away from the finished product. But in order for something to stand up, this would be a hollow space. If you were building that out of bricks, you'd have to have something to hold it there. Sometimes some fancy printers this is actually a dissolvable support system that you can put in water and it dissolves away. Most printers, it's going to look more like this. Don't just ignore the white part, where it's part of your plastic is going to be used for the support, and then you physically break it off and kind of sand off any rough spots. This is something you want to avoid. Sometimes you can't avoid it. Sometimes you just need there to be a hole or a groove or something in a particular place, and it's not very big, but it really needs to be there, and you're going to have support. But most of the time, you want to minimize the amount of support you need because it wastes plastic. You can't use this plastic. It's, just kind of becomes this crumbly dust once you take it off. And it's also inefficient in terms of use of time. Next. So the first thing you can do is when you're printing is consider how you position things. So with this X-wing spaceship here, if this were positioned in the way you want the final model to be, so that the wings were kind of going out like this, all the space underneath the wings would have to be infill. But by flipping it so that it's more like a pyramid in how it's printed, and the bottom is wider than the top, and those layers are supporting each other, then you can print it probably without any supports if it's like this, or maybe just a little bit around some of these heavier pieces and really reduce the amount of plastic you're wasting in the printing process. Next. The other thing you can do is if you have steep angles, to make them less steep. So instead of having something that is either here or here, you can have something that leans. And the general rule is if you've got an overhang of less than 45 degrees, you don't need any support. But if it's more than 45 degrees, then it'll start putting those supports. Now, sometimes you can fudge this a little and get it a little longer. If you change the settings, you can print slower, you can print at a lower temperature so that it cools faster. And sometimes you can get away with exceeding that 45-degree rule, but it's a general rule of thumb. It's a pretty good place to start. Next. The other thing you can do is you can break complex things up into simpler things and print them all separately and then put them together. For example, this, if you wanted to print underneath these legs, there would be a huge amount of support needed to support the kind of the body of this robot. But if you take the legs apart and you print all the pieces separately, not only could you do them in like different colors or something then, but you could also, it also minimizes the amount of support and infill you need to print them. So these are just a few projects that I started off with. I actually got into 3D printing a little bit before the HamPie group for work. And if you would next. So I work in a lab. And so these are some things that I, with no prior CAD training, learned to do from a tutorial given by one of my colleagues at a maker group meeting at NC State. And so I don't know if you can see this super well, but this is a holder for a little Petri dish plate that then this thing rotates and there's magnets on it that holds it in place so that I can change plates out very quickly on this rotating piece of lab equipment I have. I've used it to make templates for other Petri dishes. This is a really easy, simple design. I can whip out different templates in just a few minutes now because I've had to make so many of these, and this allows me when I put microbes on Petri dishes to put them in very precise patterns so that I get consistent inoculation patterns if I want to look for interactions with them. This is a holder for a camera because I wanted to take pictures of something that was moving in this piece of lab equipment over time. And so it was a really good way to position the camera at exactly the right focal point. And this is hooked up to a Raspberry Pi that then takes automated images. And then for Christmas this year, everyone in my lab got their own personalized tube holders that have their names on it so no one can mess with your stuff. So it's a great way you can personalize. It's very easy to add text to 3D prints. So if you want to make personalized gifts, it's a great way to do it. Next. It's also useful around the house, not just for radio things, but here is a very poorly made towel rack that we had that had one weld point that failed. I can't weld, but I can print. So I printed out a part to splice it together. This would have been really hard to fix otherwise because I would have been just like gluing a tiny piece balanced on top. But with printed pieces, I could, even though the shape was very irregular, make something that spliced it together, and probably it's stronger now than it was when I first bought it. And it's also slightly taller, so I can put bigger towels on it. So this is a win-win. But we're here for radio. So enough about my other projects. Let's talk about some radio-specific applications for 3D printing. So the first thing, this is Aurora being too lazy and too busy to go to the hardware store. I'm sure they make these, but I had company coming. My ham shack is also my guest room. So I had just put an antenna through the ceiling and it looked really ugly. So while I was trying to get the rest of my out of control electronics bench in order, I quickly, in less time that it took me to drive, would take me to drive to Home Depot, and Tinkercad designed a little thing to make it look nicer and more finished. Grommet, is that what we call these? I thought, okay, a grommet. And then while I was organizing, my printer was doing the work, printing it out. And then I could just glue it up and it looks, you know, there's still an antenna coming through my ceiling, but it looks a little more professional. This is probably my favorite project to date because it's something that I've trying to learn Morse code, but I'm still just putting my little pinky toes in the water of it. And I wanted something that I could practice with, but I didn't want to spend an arm and a leg for a keyer. So I found on Thingiverse, and on the last slide, it's got the thing file if you want to make this. Another ham in our group has already made the same one. So this is a 3D printed keyer. There's magnets that fit inside, and I would add there's a whole bunch of these on the Thingiverse. I picked this model specifically because A, it used magnets instead of springs to help the key paddles go back open, which I like, kind of the smoothness of that. And B, because it was in metric, and I had a whole bunch of whatever screws in a box already, so I could use hardware that I already had. If you have a bunch of non-metric stuff, you may want to use a different file. There's other versions of this that are meant for American screws. Next. So I will add, with the hardware I had to put some extra spacers in terms of, they would have taken an exorbitant amount of washers. So I actually put a little nut in there to space it out right. There is a wire connected here to the central conductor, and then basically when you hit here, it completes the circuit this way. If you hit on this side, it completes the circuit this way. And anytime you hit, the magnets very nicely make it go apart. And here's the finished thing. It's got a little box that goes over the top of it. The other reason I picked this design is because this is really lightweight. That is one of the downsides to using plastic for this, is that your key can move around, which can be hard, and you don't want to have to hold it the whole time. This design also comes with some built-in places you can screw it onto a board or attach magnets underneath it and stick it on your radio, and then it won't wiggle around so much. So that's kind of a nice design feature that whoever remixed this one put in, and I really like. Some other things in progress. This is the attic that's in my antenna, the antenna that's in my attic. And this was not something I printed for it. This is just a scrap piece of plastic that I had in my I can't throw anything away because it might be useful box. And I was like, I need something for strain relief, so I'll just drill some holes in this. And that is leftover plastic from a lab project that is now just being used for my very podunk 10-meter antenna. For a slightly more professional antenna, I want to make a 40-meter one. I just printed out this, and this is going to be, there's some holes, some nicer holes, more evenly spaced for strain relief, and then I can put the connections and the wires in here, and then hang it. And then I'm also working on an in-fed half-wave antenna that this is the 3D casing for, and that's going to be part of a POTA station. So lots of useful antenna things. I also want to highlight some other work done by people in the Ham Pie group. This is stuff that Ben Williams very graciously shared some pictures of things that he's done. He has built an amazing, and I'm just going to give a plug for you, Ben, if you ever want to give a talk about it, it'd be really nice. He's built an amazing antenna rotor that's for tracking satellites, and he designed and printed a part that would allow him to attach his arrow antenna to a beam that is then moved by the rotor. Next. He also printed a back plate that has some big holes in it for the fan for his whisper transmitter. And he has built the same keyer and says it works great. And also a stand for a QCX Mini, which is a small CW. It's meant for very portable operations. It's really lightweight, but this is nice because you can turn it around, and like this protects the knobs when you're taking it someplace, and then you've got a little stand that holds it upright. So really cool stuff that other people in the group are doing too. And with that, I will take any questions. Yeah.
I saw in one of your images that you had
Whoa, whoa. Oh, sorry. We got to get you the mic so everyone can hear you online.
So the Zoomers can hear.
I saw in one of your images that you had a Quiditech printer. Was that a stock photo, or is that your printer?
That is that is a stock photo, yes, but it's also my printer.
Cool, because I have one too, and I've never used it. I've never been able to get it working. So
well,
we need to talk.
Yeah. I will. It doesn't. Mine I had to look up the instructions for. They weren't readily apparent and
Yeah.
readily translated.
Yeah, we struggled with it for a while. I think it has the heated plate on it.
It does.
Yeah, it's got some neat features. We could print some of the stuff that came on the demo SD card,
Mhm.
but we couldn't. A, I didn't know how to slice. B, at the time I didn't know how to create. But now I have Tinkercad and I have a printer and I have Cura, the slicer. So I need to put it all together and make it work.
There is a specific for the printer. If you go to their website,
Is there?
they have their own slicer too.
Okay.
So if a third party one doesn't work, go to their website and download the one for them. That's the one I always use for
Okay.
it.
It was not clear, so it was like we struggled with it and then ended up not using it, and it got put in a corner, and now I just want to use it again. So
Yeah, and if you run into problems, you know how to contact me. I'd
Yes.
be happy to come over and help you
Yes.
tinker with it.
thank you.
You also have to level it pretty seriously the first time you use it, because sometimes it doesn't. Like I've only had to level mine once. Once when I started, and once when I moved it to a new place, and I just put it on the floor because it's got those motors are very strong, and the desk I had it on was going every time that I was printing with it. I was like, I'm just gonna put you on the floor, and you're just gonna be here now.
Any other questions in the room? How much does it cost?
How much does it cost per print or for a printer?
The printer and the materials.
So the printer I showed you that was open, the open, which was what's the name of those things? An entry level Ender. I don't know what the number they have it is now, maybe 2 or 3, is usually around $200. The filament costs about $20, $15, depending what brand you get, a roll, and that lasts forever. Like I could print hundreds of antenna supports out of one roll of filament, especially if you're not printing with solid infill. So the actual price of parts, like, or pennies or dollars, like it's not a lot. It's less than most of the time that the comparable hardware would be. Now it might not be as strong as something like PVC though, so your mileage may vary with that. The printer I have, I got it as a gift, so I didn't pay for it, so I don't know exactly how much it costs, but I think that is more in the between $300 and $400 range, and it's a slightly nicer printer. But an Ender is like, Ben prints all his stuff with an Ender, and like many of my colleagues at work use them in their labs and have gotten good results. They require, like, it comes as a part taken apart as a kit. Like you really have to assemble it when you get it. If you want something that's more plug and play, something like the kitty print, however it's pronounced, it's probably like more plug and play ish. But even then I had to put a few parts together when I got it, but it wasn't hard.
Any other questions in the room? I have a question. There's a question?
Did you have a question?
I was curious, just as far as like time to print something. I don't know what to use an example, like your paddle you made. Is that 10 minutes or an hour or 5 hours?
Okay. Maybe can we go back? So, or go back. I'm trying to remember how long these took, because I printed in a couple different colors. So these maybe an hour to print. Like this is very small and fairly lightweight. This big part, an hour or 2. I've printed. Go back to the slide for like stuff from my lab. Like that printed in less than an hour. Yeah, keep going. So these are pretty. There's a lot of plastic in that. These took like all day to print, like 8 hours or so, because they're almost solid and there's a lot of holes. Something like this, which is about this big around and this thick in real life, an hour and a half. It's not fast, but the nice thing is it's doing it while you're doing something else. I have run into problems with the humidity gets too high that my printer filament snaps, and I have to babysit a little more to make sure that it's not in danger of doing that and kind of loosen the filament. But at times of year when the air conditioner or the heater is running, I can usually just like set something up, go to work and come back and it's printed. Some people, there's a really fun software package for like people who just really want to geek out and control their printer from remotely. There's a thing called Octopi or Octoprint, and you can use a Raspberry Pi and a camera to monitor your thing from afar, and actually it's meant to interface with like the Ender printers because they're open source, and you can hack them and do things with them fairly easily. But then you can like from your remote thing, SSH into your Pi and tell it, turn off the printer or pause for a while because there's been a problem and I want to come back to fix it. But that's, you can make things as complicated as you want. That's probably more complicated than an entry-level person would be interested
So
in.
in that, how reliable, like if you're going to print that, and that's 8 hours to print, what's the chances it's going to work as opposed to fail halfway into it?
If the humidity is fine, 90%. But if my filament has gotten wet, lower. But they're so cheap. And also like you can remelt the filament and the remelt. I'm actually saving these things. If you wanted to really get into it and you wanted to like save every bit of filament, they make re-extruders, but that's less cost effective in my opinion. I'm saving the filament because you can melt it. You can melt it in your oven and you can make like, in a mold, and you could make coasters or whatever out of it, so you can reuse it. It's the nice thing about PLA. I would never want to do that with ABS again because of the fumes, and I wouldn't want the fumes in my something I'm cooking in. But PLA, because it's food safe, would be fine to do something like that with. I only print in PLA because I don't have the ventilation for anything else other than that. And also because I'm learning. And so I do want to point out that if you've never done CAD design before, or if you're new to 3D printing, it is an iterative process. You will print more than one thing sometimes while you're learning to do it. And especially for my lab equipment, when I would be like, oh, I measured this like a few millimeters off and it doesn't quite fit, I have to reprint it, kind of thing. You get good at learning that you should always make the holes slightly larger than you want them, because it's always easier to fit something in a too large hole, but the hole's too small, like it's over, it's done, you have to reprint it. So the design process can be time intensive if you're doing something that's complex, but it's fun.
Are there any questions on Zoom? No hand. I have a question, and it's kind of along with what Barry was saying. If you've never done it before, and that one of the slides you had, you said you can print it slower so it cools if it's, if there's a problem. Sounds like there's a lot of parameters to set up for printing.
There are like for my printer, the default usually works.
Okay, because I was at the same place. If you have a lot of setup parameters, and how many times does it take you till you actually learn how to do it right, before you get your test tube holder or whatever it is. And
so the place where you run into problems is something that has a lot of like gaps and bridges. Yeah. Like that's where, like, don't print those kind of things when you're learning. Start with things that like you could build it out of sand and as a sandcastle. If it would be easy to build as a sandcastle, it's easy to print. So, start, like, I was really ambitious. My first project was this thing, which didn't fit on my printer. I had to print out 2 parts and like figure out ways to like securely put them together so that I could fit, because my device that has these magnets on it, and I needed it to like magnetically like attach so I could take it on and off easily. And it was just like 2 centimeters wider than my printer bed was. So the thing that I've tried to do print first, like that is like version 3 or 4 of it. And it was way more complicated than many things I printed later on. Things I printed later on, I was just like, oh, it's easy after trying to like, do this super hard thing the first time.
I watched one thing getting done that our nephew was printing. He has a 3D printer, and he made a boat for me. So it's probably, I don't know, maybe 4 inches long. The sides are probably 1.5 inches, and it has a mast in it, and it took him hours. We were over there for dinner for some reason, I don't know, but he started it before dinner and it finished up sometime later in the day. But it's really neat. I mean, he had some of the supports inside that we had to cut out because it had to hold the sides together. They wouldn't fall in, but that was pretty neat. Another question.
So it's not so much a question, but the Durham Public Library downtown has a room full of printers.
Oh,
so the other libraries might have them too. I know they have at least 5 or 6, and it's pretty inexpensive.
Note to
play with.
self, write Hillsborough Public Library so that everyone here can do it too. That's really good to know that that they have it there. I mean, at State, they have maker spaces in several of the libraries that, you know, I'm blessed that if I wanted to print something that larger than my printer could have, I have a lot of options. But I also like using my own stuff because then it's easier to tweak. So that's really good to know. There are public resources out there for printing things if you want to dabble, but you don't want to own.
Yeah, Aurora,
Any other questions for Aurora?
question on Zoom?
Right on. Any other questions for Aurora?
On Zoom?
Okay.
Yeah, I've got a question. I don't know if you're hearing me or not.
Yep.
Oh, okay, yeah, Aurora, really interesting presentation. That's the best I've seen, and gets me interested in doing it. But I'm curious how you, and maybe I missed it. How do you attach things together? Can you design things that snap together, or do you have to bond them or glue them? For example, if you wanted to make a little platform with 3 legs to it, like a tripod, how do you attach the legs to the body? Can you design it to snap or glue?
So yeah, usually you use glue. I mean, you can friction fit things, and you know that works as well. It's sort of like, you know, if you want to, in carpentry, if you want to attach something with pegs, you know, it'll friction fit as well as the pegs work, and then until it doesn't. So it's almost always better to glue. Most people use either super glue or hot glue. Super glue is, or you could use like Gorilla, you know, like the Gorilla Glue. That's like the two epoxy that you mix the 2 things together if you wanted a super strong bond. I frequently just use hot glue because it's comparable, you know, it's either super glue. I frequently use hot glue because sometimes I have to take pieces apart, and I can actually do that with a hot glue. And then once I have it where I want it, I'll super glue it. And what I usually do when I have to put, like this one here, I don't know whether you can, these pieces were the ones that were just like slightly too long. And so
She's pointing at the left picture on the slide, John.
okay, sorry, you can't see me. But what I did was I printed something that has like an indentation of like, I made the big, okay, I gotta some way of drawing this. I wish I could draw. Yeah, but like I make a groove where the piece is going to go to, because if you just like glue it flat, it's not going to be a very strong joint. But if you make a groove and then you fit it in and then you layer another piece over the top, then you get a really strong joint. It's very similar to carpentry joining. So you can any of the kind of joints or ways you would attach things with pegs and carpentry, you can attach things with 3D prints. You can friction fit, but yeah, usually glue.
Yeah, one other question too. As far as finishing, I know most of the things you have are either all green or all orange or some color. Can you multi-color print, or can you, if you wanted to just paint it a different color, spray painted a gray or black or something, can you do that?
Yeah, you can very easily paint it with like acrylic paints.
Okay.
And there's you might want to like rough it up a little bit to get really good paint adhesion, but PLA paints pretty easily. I've never tried to paint ABS because I don't print in it. It's like painting other plastic. I feel like PLA actually binds to paint better than many kind of slicker plastics because it just kind of has a very rough finish to it. If you want to print in multiple colors, there are printers that you can put multiple things of filament on. Again, those are expensive. You can also, if you want to print something half in one color, half in another color, you can stop the printer part way, take a different color filament and put it together, or you can print separate pieces and then glue them together. And they also make so there's some newer filaments that are like kind of like variegated, and that, you know, it'll start off one color and then as it'll print, it'll slowly go into a different color. And they make shiny ones, they make glow in the dark ones, they make metallic looking ones. Like you can get fancy with it. And a lot of people will print different parts in different colors and then attach them and then add final details with paint. And then like maybe spray some acrylic over the whole thing to kind of like keep it all nice. So you can absolutely do that. I'm not artistic. I just want it to work.
But maybe one last question. You covered an awful lot of material and ideas and everything. I'll probably forget some of this by the time I wake up tomorrow.
Well, I think this is recorded, right?
Oh, well, yeah, well, I can do that. But I wonder if you have any like websites or YouTube things or anything like that you recommend to go to learn some of the things, again, like you've described? There's a lot of material.
I mean, I feel like YouTube is just flush with, like, if you just Google, like, if you go to YouTube and just be like intro to 3D printing, there are people who probably give much more detail oriented talk. This is very much a like basic overview,
Right.
my talk. But if you want a ham radio specific one, there are people who talk about ham radio specific things. And if you look back on the slides for this, many of these things were taken from 3D printing websites, many of my images in the first part of my talk. So you can go to any of those, just go to the kind of the beginning part of the URL, and there's a lot of tutorials online for those too. So there's a wealth of resources online. It's kind of overwhelming, actually.
And John, like all of the membership meetings, this is being recorded. It will be posted on YouTube. So all of the URLs that were on Aurora's slides will be part of the presentation. So you can see all of those.
Yeah, and we can share, if you want, we could also share the slides with just the PowerPoint slides so people could just click on them or copy and paste them easily.
I tried to send the slides to Dan so we could see our presentation.
Mhm.
And I think maybe because of your
You may want to take my video out
take the
before
video
you send
out.
it,
Yeah,
because it's a
it was
really
like,
big.
I don't know, 38 meg or something like
Yeah,
that.
take the video out and then send them.
Yeah, I changed it to PDF and it was 5 meg.
Yeah.
No
Yeah.
video. Any other questions in the room? Aurora, fantastic job. We're up.
Thank you.